So let's go ahead and take a look at some of our integration formulas now that we've got for exponential functions and logarithmic functions. So the first one is, let's call this number one. Now let me slide it over a little bit. The right's better over here. So number one is the integral of e to the x dx. So what we're looking for is some function here so that when we differentiate it, we get e to the x. So we got to find the function f. Well, that's pretty easy to do, okay, because we know that the derivative of e to the x is itself e to the x. So the integral of e to the x dx is equal to e to the x plus that constant of integration. If you differentiate this, guys, you end up with the inside piece. So that one's pretty easy. Okay, number two is we want to integrate b to the x dx. Okay. Now the problem with this guy here is we're looking for a function who, when we differentiate it, we get b to the x. So we want this to be equal to some function f of x such that when we take the derivative of it, we get b to the x. Now let's go ahead and let's just assume that f of x, if f of x was equal to b to the x and we differentiated this, then we get f prime of x is equal to the natural log of b times b to the x. So we're higher than what we need to be by a natural log b. So what we're going to do is we're just going to divide this by the natural log of b. Of course, we'll add our c, just like that. Okay. So part 3, this one's a little bit more tricky. So we've got 1 over x dx, and we want to find a function whose derivative is 1 over x. Well, now here's the thing though. Our x values over here, this is not restricted to just positive numbers. The only restriction here is that x is not 0 on this function. So we got to be a little bit careful. Okay. Now, I'm going to split this into two cases. If x is positive, no problem. Then let's let f of x be equal to the natural log of x. And then therefore f prime of x is equal to 1 over x. So we get this guy on the inside. But what if x is negative? See, there are no restrictions here on x. Okay, so let's work our way backward. If x is negative, then negative x is positive. So what if we take f of x and let it be equal to the natural log of negative x, where this guy is positive? Now let's go ahead and differentiate. Well, when we take the derivative of this, let's use the chain rule here. Okay, so let's let u be equal to negative x. So this is the natural log of u. And so we know that its derivative is du dx times 1 over u. Well, du dx is negative 1, and this is 1 over negative x. So this ends up still being just 1 over x. So if x is positive, we let it be equal to just x, and we plug it in, and we go and we get the answer out. If x is negative, we let it be equal to negative x. So this right here, guys, this idea is the absolute value function. So what we could say is we take the integral of 1 over x d to the x, that's equal to the natural log of the absolute value. And what this does is this guarantees that for any x value, I can plug it into here and I'm good as long as x is not 0. So as long as x is not 0, if I differentiate this guy, I've shown it in 2 different steps, I always get 1 over x, the guy on the inside. So this is what we're looking for our antiderivative.